Good morning. This is the Colorado Energy and Carbon Management Commission. It is October 16th, and we will take a roll call.
Thank you, Mr. Chair. Commissioner Ackerman, Commissioner Cross,
Present.
Commissioner McGowan,
Here.
Commissioner Mesner,
Here.
Commissioner Oath, Commissioner Ray, Commissioner Robbins.
Here.
Mr. Chair, you have 4 out of 7 commissioners present.
Very good. Welcome, everybody. This is a special meeting of the Colorado Energy and Carbon Management Commission. We are gathered here today to hear a report concerning methane emissions from abandoned oil and gas wells in Colorado, which was prepared by Colorado State University. I believe the order of play, and Hearings Manager Larson, let me know, is we're going to hear from Stuart Riddick, the author of the report, and then we're going to hear a little bit from staff. Is that right? You're muted.
Thank you. We're looking for, you're correct. We're looking for Mr. Riddick now in the attendee list, and he's not yet in. So just give us a moment, and we will, for him to arrive, and we'll get him in.
Okay. Why don't we do this, Ms. Larson? Let's just take kind of a temporal break. And then once we see you visualize yourself again, then we'll know that you're ready to go.
Perfect.
All right, commissioners, you can take a quick break.
All right, Mr. Chair, we have Mr. Riddick with us, and we are ready to go.
All right, fantastic. Good to see you, Mr. Riddick. Thanks for presenting to us. The floor is yours.
Oh, thank you very much. Just share my screen. Can you see? Oh, no, wait there. Does that come up?
Yeah, that comes up. It's not in presentation mode, if that makes a difference. Yeah. There you go. Perfect.
There you go. All right, thank you very much. Well, thanks for inviting me to talk about findings of my study. And so this was a study to go out and measure the methane emissions from Colorado abandoned wells. And I'm Stuart Riddick. I'm a research scientist at Colorado State University's METEC group. We're part of the Energy Institute, and METEC stands for the Methane Emission Technology Evaluation Center. And the director's Dan Zimmerly, so you probably know Dan and heard his name around. So agenda today, what I'd like to do is I would like to run through different parts of the project, but an introduction to abandoned wells, and to just give a glossary essentially of what we'll be talking about today. Look then at non-Colorado emission factors, so literature review of what's out there. So what other the emissions from other states are for plugged and unplugged abandoned wells. Then I'll run through the Colorado measurements. These are just the results that gathered, and then patterns in emission. Then we'll leave some time for discussion at the end. So an introduction to abandoned wells, and abandoned wells have become more of an interest in research circles since 2012, where the first measurements were made in Pennsylvania, and it was Mary Kang working with Mike Celia and Denise Mazerel that started it. But what I'd like to do is I'd like to talk about some of the definitions that the EPA use, and these are definitions that I've been using, and it just puts us all on the same page. So the term abandoned well describes the whole gamut of wells. So these are those with no recent production and not plugged. And these other terms can be inactive, temporarily abandoned, shut in, dormant, and idle. They can also be wells that have no recent production and no responsible owner. So they would be termed as orphaned, deserted, long-term idle, abandoned again, and owners who have become bankrupt. And the third subset of abandoned wells are wells that have been plugged to prevent migration of fluids or gases. And this gives you a spreadsheet or a flow diagram of the abandoned wells. So at the top here, you have an active well. 12 months after last oil and gas produced, it then becomes inactive, abandoned, drilled, or completed. So these are what happens after 12 months of non-production of oil and gas. These can either be permitted to become shut in or temporarily abandoned. If the operator goes bankrupt, these then become non-producing orphaned wells, if the operator opts to plug, these can become plugged and abandoned, but you can also restart production at any time and it goes back to being an abandoned well. There's another subset of wells that the EPA have, and this is just for interest, are the pre-1975 abandoned wells. And in their emissions inventory, these are assumed to be plugged. So to review literature to see what other states are reporting as emitted wells, and these come from peer-reviewed publications. We have, hopefully you can see this. I'm just over here. So this is taken from a range of different papers. With the lead author, the year that these were published, the state and province that started looking at Canadian ones as well, lumped them in, but I've removed those for the further analysis. Whether these are plugged or unplugged wells, and the average emission. The emissions then come with uncertainties, which vary from plus 100 to minus 50% to much tighter uncertainty bounds, depending on the methods used to quantify the emissions. And then we've got the number of wells measured. Only some states have measured around 100 wells, but these are actually quite few states have representative numbers of wells. And I just pick 100 as a sort of sensible sample size of what you could see as something that is representative. But the other thing that in here is particularly interesting is the method of well selection. We have papers that have no description of how the wells are chosen, some that are that only choose high emitting wells to be chosen, other ones that screen for wells and then pick a subset of the screen. But the ones that I think are probably the fairest representation of wells, or a method, will be those that are randomly selected from a database. So that's getting a database and then choosing a subset from those just at random without any reason for doing it. One of the other reasons that a lot of wells are chosen is access. Access can be a problem. So to actually go onto someone's land and then measure the wells, not everyone's enthusiastic about that. But when you put this onto a bar chart, we can see from California, Ohio, Oklahoma, Pennsylvania, Texas, and West Virginia. These are the only states that we have representative emissions from, or studies done. And then those studies that have 100. So the filled in circles are the unplugged wells. And these are the circles of the number of wells measured in total in the studies. So if you like, California for plugged wells, Oklahoma for unplugged wells, Pennsylvania for unplugged wells, and West Virginia for plugged and unplugged wells, you're getting a representative sample size of over 100. And you see here the emissions vary from state to state, but when you then add in the number of wells measured, we can see that the total emission from unplugged wells is running around 7.5 grams per hour, whereas plugged wells, we're getting an estimate of 1.2. That's the number, that's 1.2 grams per hour. So that's the total US. These are slightly different from the EPA emission factors because they chose just 3 of those papers. But this is I would say, a more comprehensive review of literature. So this gives you an idea of what we're dealing with. To put it in sort of perspective, 4 grams an hour is what a deer will, the entire fermentation from one deer. A head of cattle would be around 10 grams an hour. So that puts it in perspective of what we're talking about in terms of how much of the average well emits from each of these studies. Any questions so far? We'll just carry on.
A couple of questions, if you don't mind.
Sure.
Going back to the previous slide, you mentioned uncertainty. What does that mean? I'm not familiar.
Yeah, so it's well, a method will have an associated uncertainty. So depending on your measurement technique, for instance, you can enclose these enclose the wellheads within a chamber, a static chamber, and then take gas samples at time intervals and then calculate the concentration, how the concentration changes over time, and then you get an emission. But there's an associated uncertainty with either the concentration measurement or the approach that's used. We've done some work at METEC constraining these these uncertainties that are associated with measurement, and certain methods. For instance, Natalie Peckney's paper here from Pennsylvania, they used a high flow sampler. So that's a device that you can place over the well. It's like a large vacuum cleaner. You suck the gas, the air through, and the gas that's emitted from the well. It then quantifies the concentration and then gives you an emission estimate from that, depending on the flow rate. So these are uncertainties that are associated with different methods. Is that clear?
Okay. Yeah, I think that helps. And then I find it interesting that some of the studies sampled one well or two wells or a minimum of 5. I mean, is that really a study if they're only sampling 1 or 2 wells?
It depends what you're doing, because if you sort of take my I got a 2020 paper here from Pennsylvania. So this was Pennsylvania and West Virginia together. So we reported on the 13 wells, but what the actual study was quantifying or observing how methane emissions changed over time. So what we're looking for is, we put a chamber over the well and left it for 24 hours. And then we measured how the concentration changed and then inferred an emission change over time. So it was, the previous thinking was that methane emissions were constant from these wells. If you measured last week and this week, they would be the same, or this time last year and now, they would be the same value. But what we were actually finding in that study was that there were large changes in concentration even over 24 hours. And it was, you know, some wells you go to, you can see bubbles forming in the ground. And so depending on the amount of gas that's forcing its way through or how much water there is, it changes the emission rate. So these studies, some of them were simply to quantify emissions from a state. Other ones were looking at particular behavior. And from that, we could leverage an average emission from those studies.
Okay, all right. Commissioner Messner unmuted and Commissioner McGowan raised her hand, so I'll let you guys fight it out.
Go ahead, Commissioner McGowan. You raised your hand. I did not. And I will ask a question after you.
Okay, thank you. Thanks, Mr. Riddick. So when I looked at, I think one of the purposes of the study was to figure out what other states had looked at their plugged and unplugged wells from their orphan programs, perhaps, and kind of figure out how does our state compare. But when I look at the other states, I'm wondering if you have an opinion or if you know enough about what happens in the other states to talk about, do we P&A our wells similarly? Is the way that we drill different? Is how, in addition to the fact that some of these studies don't have enough sampling, I think, to be statistically significant and to kind of give us relevant data to compare. I think some of these states maybe are different from Colorado in other ways. I mean, so I'm trying to see if there are states that we look like us, or what. I'm just wondering if you have thoughts about that.
Sure. These studies, you know, the first studies took place in Appalachia. So you go West Virginia. I spent quite a lot of time. I was part of the Princeton group that started the study it was 2012, and then I joined in 2015 and took over the project. West Virginia looks very different to Colorado. A lot of the wells that we measured there, the unplugged and plugged, were the actual operations or the production happened around 1860, you know, to the turn of the century. So these are very, very old wells. There's places like Volcano in West Virginia that you still have the wooden butts that were collecting oil, and they're preserved because they were collecting oil. It's the wood is still there, but you've got all the old infrastructure that's happening. These aren't emitting an awful lot. You can see here West Virginia was around about 4 grams an hour on average. So these are very, very historical wells that were from the start of production in the US. So I would say it's a very different scenario that you've got here. And we were measuring quite a lot in state parks. So these weren't primary production areas today. In West Virginia, they moved into doing a lot of horizontal wells. These were vertical wells that were just drilled. And as I say, happened a long time ago. Plugging was when I spoke to the what they called the rangers who were in the state parks. Historically, plugging would be 2 tree trunks and 3 bags of cement that were thrown into the well bore, and you would just let that sit, and then that's what you would call a plugged well. Very different to what you have you have in Colorado now. So that would then mean that if a well, even some wells that were plugged in West Virginia, you would see some emission, but typically you wouldn't see an awful lot. You see there the average is less than 1 gram an hour. So West Virginia is quite similar to Pennsylvania, and the wells I saw in Pennsylvania were typically like West Virginia. This may be slightly skewed because one of the papers that was used to generate this was quantifying emissions from high emitting oil and gas wells or abandoned. So the actual study was looking at large emitting wells. So I think, as I said in the previous slide, you've got to choose your sample that you're comparing to quite carefully, depending on how much you believe either the uncertainty in the measurements or the method of well selection. So I think you got to be quite judicious in your comparison. And you'll see here that highlighted, these 4 that are highlighted up here, you get very, very small emissions from California, West Virginia, Ohio, and the Western US. And this is a paper that was left on because it didn't disaggregate between Utah, Texas, and Colorado. So I didn't include that in the graph. But you can see here that the sample sizes were quite high and the emissions were very low. And the same sort of down here where you've got largish emissions. And you see here, there aren't a lot of unplugged wells that have been measured. Here we have sort of West Virginia, Oklahoma are and they're coming in roughly the same numbers, about 3 grams an hour. So that kind of gives you an idea.
Thank you.
Answer your question, or a bit too long-winded? I don't know.
Yeah, I'm just, as I was reading it, and you and I have actually talked a couple of times, it's like we're trying to compare apples to apples, but it's now almost comparing different kinds of apples. So we can kind of compare, but not, we have to be careful about how we compare.
I think that's absolutely true. And you've got to have some perspective on, when potentially was last production, that seems to be a driver, but it's not strongly correlated, as you'll see as we go along. And it is very much is it an historic area as opposed to a recently producing area? And I think you're going to have a few effects that are happening there as well. So I think you've got to provide some context in order to do your comparisons. There potentially will be recently producing wells in West Virginia that just haven't been measured. If you think there are 3.1 million abandoned wells, and we're trying to pull out a number here based on 400 measurements, I don't think it's reasonable to assume that, but it takes quite a long time to go and measure more than 100 wells. So that's a key difficulty here that we've got.
Thank you.
Commissioner Messner?
Thank you, Mr. Chair. I mean, I think my question along the similar lines on the next slide was trying to better understand why there was, I guess, higher emission rates associated with plugged wells in Oklahoma and Pennsylvania. And it sounds like what you're indicating is that due to the age of those wells and potentially the mechanisms that were utilized to plug them, that may determine why that that emissions rate is higher. Because Oklahoma, Texas, I guess you would assume that there's some similarities there, but Texas's numbers appear to be much different than Oklahoma's in regards to emissions associated with plugged wells. Unplugged wells is a different beast altogether, because I think that probably has a lot to do with type of well, depth of well, geologic layer that they're trying to access with it and such. But seems like plugged wells should have more similarities than unplugged wells.
Mm. And as you say, it comes down to the method that were plugged, when they were plugged, and stability of the ground around the plugged well is very difficult to know from this sort of small sample size. As I say, that historic methods of plugging are not particularly robust. And
okay. So let me continue listening. I'm sure that some of this will get sorted out further in the presentation. So thank you.
Okay, great. So this is just to give you an idea. So the total US average, you can say for unplugged, about 8 grams an hour, and unplugged is less than 2. So there we go. Average in the US, 388 plug wells, and bearing in mind that this is trying to be representative of the 3.1 million wells that are in the US. So sample size here is key. But plugged wells, the emissions are much lower than for unplugged wells, but relatively small numbers. If you look at, that's about a quarter of, about half a deer, sorry, and 2 deer, if you're going to put it into, context of animals. So the Colorado measurement campaign, so myself and colleagues at METEC went out to measure wells between August 22 and April 2023. We measured methane emissions from 108 plugged and 226 unplugged wells in 17 counties and from 63 oil and gas fields in Colorado. So we tried to get a geographic spread of the key regions that you would see. And there we have sort of the plugged wells are white circles and unplugged in red circles. So this gives you a spread of the wells we used, and we took the wells mostly from the orphaned well list that COGCC, which is ECMC, I think, sorry, they provided for us. So you see here, there's a big collection around the airport there, just to the east of Denver. But we tried to visit as many as possible to get an idea of how the geography might spread. Plugged wells throughout the state were 0. We didn't see one plugged well that was emitting, and that potentially, so we measured 108, 100% were 0. We remeasured 36, and there was 0 emissions from those. So it provides good evidence to suggest that plugging in Colorado is effective. So once a well's filled with concrete, cut, capped, and then covered in, I think it was 3 feet of soil, then the measurements at the surface were 0. And that's all I'll say to that, is that we did not detect any emissions from any of the 108 wells that we measured. And that goes back to when they were plugged. So there were quite a few that were plugged in 2020. It goes back to 1960. And pre-1960, I just clumped as 1900. So we had data on whether they're plugged until 1960, and then anything after that, I just assumed was 1900 as a nice round number. So irrespective of date of plugging, it seems to be holding the gas in the ground. Unplugged wells, we measured 226. 44 of those were not emitting. So on a screening, we took our gas analyzer and screened around the wellhead completely. And 44 of those we could not detect methane at. That means that 56% of these were emitting. The largest was emitting at 76 kilograms of methane per hour, and the average of these 226 was 534 grams of methane per hour. And this shows the long-tail distribution. If you, on the y-axis here, we've got a log scale, but it shows a long-tail distribution that you typically see for oil and gas operations, where you'll see a long tail, and the heavy left skew are the things that contribute the majority of emissions to the actual total. So this is quite typical of what you'll see other well pads and for different pieces of equipment. So this is what we would expect to see. Repeat measurements. The circles are the original measurements, and the crosses are the repeat measurements. And you'll see that of the wells that were measured, there were some that started emitting in between. It was roughly about 3 months from our initial measurement to repeat measurement. It was roughly 3 months between those. So you got 87 there that started emitting. Any that were emitting when we originally went emitted much less by the time we got back. I've taken off the really big emitter here because it makes it, you can't see the detail. But everything that we saw reduced in emission when we got back to it. So if it was originally emitting over 3 months, it would reduce. And the really big emitter, it was emitting about 75 kilograms an hour. We went back a month later, it was emitting around 60. And then when we did a repeat measurement after 4 months after the first measurement, it was down to about 20 kilograms an hour. So you've got a very large, quite a marked exponential decay in emission. So we did see this at most of the sites here, that anything that was emitting over time would be naturally would reduce in emissions. And we think this is possibly to do with potentially gas had been, the pressure at the reservoir had decreased enough, or more likely to do with liquids entering the wellbore and stopping gas emitting over time. So if you got rain or anything washing into the wellbore, if gas has forced its way through, it requires a pressure in order to force its way past this blockage. And then over time, as more things drop down into the wellbore, and the gas depletes in pressure, it's going to stop the emissions. So that's our repeat measurements. Any questions on what we saw in Colorado?
Commissioner McGowan?
Thank you, Mr. Chair. So, Mr. Riddick, could you go back to the slide of the average and the largest? Okay.
This one?
Yeah,
Yep.
Thank you. So that one, that's the largest, the 76 kilograms. Were there any other that were that significantly large? And what happens when I'm assuming that large number affects the average.
Yeah. So yeah, it skews it very much. So you don't have normally distributed emission. So yes, you're talking about a very large emitting well. We saw one, the highest was 75. The other one that we saw that was about 33, and then it dropped down to, I think it was about 10 kilograms an hour. So we did a very small number of very high emitting wells, and as I say, this is typically what you would see in oil and gas. And this never been seen before, and it could possibly be to do with the size of the sample size of the survey. If you sample enough, you potentially could see this, or it could be something slightly different in Colorado that you might not see anywhere else. So we can't make any definite conclusions about that, but you know, this is, you know, the observation. So yes, the average would be, you know, moved up considerably by this really high emission. That's the question.
Yeah, I'm trying to, I guess I'm trying to figure out is if we were to say like, oh, on average in Colorado, the average unplugged well is emitting 534 grams an hour. Do we really think that, or do we think it's something different with a couple of
Yeah,
hours?
it's a statistical quirk, isn't it? Yeah.
Yeah,
What we could do, and I was speaking to Dan Zimmerly about these, and Greg brought it up. I can't remember Greg's surname, but from Adams County. But what has been done in the past is some Monte Carlo analysis with these really large emissions. So you actually run many thousands of simulations with these large emissions, whether they occur or not within your sample size. And then what you then generate is a more robust estimate. So saying here average of 534 isn't statistically, it's not correct statistically, but I had, you know, this is the way it's been done in the past. You know, so we're just following a recipe, if you like. There are better ways of deriving what you would expect. The mean or the median value is, I think, 0.4 grams an hour. So, you know, that gives you a sense of what that, you know, what the emission is. So it's choosing the right metric in order to explain your data. And, you know, to date, the average has just been used, which I don't feel is particularly useful because it's not the average emission of the wells. It's not. So, yeah, it's.
I'm just trying to figure out how we put things in perspective at the end of this, and you know, what are the takeaways? And
sure.
Yeah, I appreciate that. Thank you.
Any other questions?
Commissioner Cross?
Thank you, Mr. Chair. And I want to ask, I have three questions here, and it's kind of to do with the types of wells, the location of the well, kind of the data set overall. The first is, did you, in looking at these, do you also have it broken down by the location of the wells and the type of the wells? And one of the reasons I wondered about that, I noticed in your map that you had, it was broken down. I didn't see it in the southeast corner. There was some in the southwest corner. And obviously that's a higher coal bed methane location. And so I was wondering if perhaps there was a difference in the coal bed methane wells in the southwest versus maybe something you see in the northeast. So that was my first question, is if it was also broken down by that aspect.
Yeah, so just to follow on this, I've got a breakdown, and what we found were the wells, and this is something very specific to Colorado. Around Adams County, there was a gathering line which was removed, and so it stranded a lot of wells, and the companies then went bust because they couldn't remove the product. It appears that the wellheads were then shut in, essentially, and then left until they were, you know, orphaned, and then they could be plugged. So what you've got here is a very, very different subset of wells than you would have. And if we could go back to the original, is you have active wells, and for to date, all wells that have been on this the abandoned well, or so termed abandoned, have been not producing for the last 12 months. What we actually are starting here is a subset where these have been producing recently. So these have never been measured in the US before. So instead of it being not producing, it's actually been producing and then become orphaned. So that is the massive difference of what you're finding in Colorado, is that you've got you've got wellheads that could be used for production, but because of, you know, an event that happened, these then become orphaned. So you've got a different subset, and this then comes down to your inventory values, which I think speaks of, you know, how do you how do you then translate? What do you take away from this study? Is that to date there are emission factors for, you know, non-producing orphaned, plugged and abandoned wells, but there aren't emission factors for recently producing and orphaned wells. So this is the very, very different case. And you know, there's been some studies that have come out and called for marginal wells to be shut in because this will stop emissions. And this is providing strong evidence to suggest that that's not a very good idea, because what happens is if they're shut in, their maintenance becomes zero, and they can emit large amounts of methane without anyone ever visiting the site. So that's a key difference of what we're seeing here, and adding to the science of abandoned wells.
Yeah. One of the other questions I had on kind of the subset, and I guess with respect to what was plugged, it didn't really matter because you weren't seeing emissions at all with what was plugged. But I was wondering if, because you looked at the date of the plug-in, did you also look at the date of the drill? So for those that are not yet plugged, was there a difference in emissions in the much older wells versus some of the newer?
Yeah, it's a problem that's cropped up with a lot of abandoned well studies. Is no one has been able to date find a relationship between any of the variables, and you know, I'll come on to this in a bit, any of the variables to do with the wells and the emission rate. And I was speaking to Mike Seeley at Princeton. He said, you're just not going to be able to understand what's happening downhole without doing a massive geological survey into what's happening in the wellbore. So that to try and identify wells which could become emitting is nigh on impossible from the data that we've got at present. There's another group that are starting at Berkeley that this is their goal. They want to find which wells are most likely to emit. And I said, well, you know, there isn't any evidence to suggest its date of drilling, its, you know, type of well. There's no real in depth. There's no real information on this because there are a lot of variables that are happening down the hole. And maybe with, you know, a better data set, by which I mean more wells being measured, you will get a better understanding of this. But without more data, it's practically impossible. So unfortunately, that's kind of the state of play at the minute.
But it is something that you did take account of when you were.
Yeah, I can. So these are correlations between unplugged wells and measured emission rates. So we've got completion year, total depth, time between last production and the measurement, the active years, the total gas production, and so that's 1,000 cubic feet, and the total production in barrel of oil equivalent. And we didn't see, so you get R squared there and gradient, and just through it. You didn't see any relationship between any of these variables and emission rate. At present, as I say, you know, sample size potentially too small in order to drag out anything meaningful from, you know, this data. As we say, you know, the really large emitter could be skewing some of these patterns, but yeah, difficult to date.
Thank you. And then my other question is, you talked about, especially for that super emitter, as you measured again later, it had decreases in emissions, and you noticed that in some of the issues. Were most of these measurements done the same time of year? So could the season or could the temperature have any effect on that as well for the increases or the decreases?
To date, well, they were all, the initial surveys were all done around from August to about December. So that's, you know, just people hours. And then the repeat measurements were done about springtime when we could get back to, you know, away from the snow. So yeah, could be. We have seen, you know, there's anecdotal evidence of on active production sites, emissions become higher in winter because, you know, you get, as the method becomes colder, it causes the gaps in the casing to increase, and so you get larger emissions. But we didn't really see that. Other studies, we did another study looking at variability in meteorology, and we found that rainfall was the thing that caused emissions the most. You know, so if you had rainfall 7 days before your measurement, the emission was higher, and it's to do with water-filled pore space. As the gas comes up into the soil, if there's space for it to travel through the soil, it can travel sideways, so it travels laterally. If the soil's filled with water, it migrates up the side of the wellbore, and that's where you capture the emission. So as it's traveling through the soil, it gets a chance to be taken up by potentially methanotrophic bacteria, and so you actually reduce your emissions. So that's one thing, but we didn't see any patterns like that. We didn't do the same extensive repeat measurements that other studies have done in the past. This was trying to get as many done as possible, but that's
Thank you.
but if you're interested, we'll we don't mind going out measuring. So.
I think you can move forward with the presentation.
Okay, so I've alluded to sort of patterns in emission, and this goes back to what I was saying previously about the gathering line and Adams County being taken away. So we saw, and this again quite highly skewed by the large emitting well, but there were 3 large emitters that were in very close proximity in Adams County. And then I've put a dash line here from West Virginia average emission. I think it's just for my reference. But you see, there's a few counties that were emitting more, but Adams was the largest by far. But also we did measure more wells in Adams County because because of the stranded wells, there were more on the orphaned well list. So that's where we were kind of directed towards and to measure there. So we measured 162 in Adams County. So it might be a factor of just doing a larger sample size as well as the gathering line. But again, as I say, we looked at correlations between well variables and measured emission rate, and nothing popped out, which is consistent with other studies. So it wasn't really a surprise. And large emitters were found typically around the Denver airport region area in Adams County. So we didn't really get any large emitters in any other parts of the state. So takeaway, I think the real positive to come out of this is that plugging Colorado is very effective. So that didn't see any plugged wells emitting. Unplugged emissions are 70 times the national average. But again, as you point out, average doesn't really mean much when you're talking about these this highly left skewed distribution. So it's not really apples to apples, as you were saying. And what we're trying to bring forward here with this study is that there are a new subset of orphaned wells, which are the recently producing orphaned wells, and these have never been observed before. So whether a study can go to recently producing wells in West Virginia or Pennsylvania and look at a company that's gone bust and say, is there, are the wells that have been shut in here, are they emitting at the same rates? And I think that'd be a really interesting thing to look at going forward. Shutting in wells as a stopgap prior to plugging doesn't seem to work, because all you're doing is you're kicking it down the line where your emissions are going to come out all at once. And just there you have all Colorado unplugged wells is an average of 534, but the recently producing wells, so we measured about 19% of the wells had production data, I think, in the last few years, and the average of that was 3.6 kilograms per year. But non-producing, so the ones that are classically orphaned wells, or abandoned wells, non-producing orphaned unplugged wells, there's 81% of those that measured, and the average was 3.9 grams of methane per hour. So it falls in line with what was seen nationally, as you have these historic wells that are not emitting an awful lot, around a deer's worth of methane. But if you've got an area where you have recent production, the unplugged wells are going to emit much more. So that's 1,000 times higher on average. And then, so this gives you, this idea that the Colorado wells, you see here, the red dot here above Colorado is the number of wells measured. It's much higher than any other state. And, if we disaggregated it into, recently producing and non recently producing, you're going to have a very, very different story. But what this does, and it's a question for the EPA to then think about, is what this does, what effect this has on the US emission factors. To date, they just have two brackets. They say plugged or unplugged. And so this is calling for some sort of better understanding of how you quantify emissions from different types of abandoned well. So whether you break it down to recently producing orphaned, there's a lot of different ways that you could cut, but it's just to highlight that this is a question that should be addressed in the future. So thank you very much. I'll take any other questions.
Thank you very much for the presentation. Commissioner McGowan will start questions.
Thank you, Mr. Chair. And no question, I just wanted to remind folks that the ECMC commissioned this study with CSU and Stewart's folks. Sorry, Professor Riddick, I don't know if I should call you. Through the Irwin Martinez Irwin funds.
Good reminder. Thank you. Commissioner Messmer.
Thank you, Mr. Chair. And Dr. Riddick, you may or may not know the answer to this, but as I'm looking at that data and I'm trying to absorb it and understand it, and certainly good news about the plugged wells and the orphan well program. Well, not only the orphan well program, but just plugged wells in general, and that level of success as far as eliminating emissions. But as you look at the unplugged wells, the shut-in wells, temporarily abandoned. I mean, all the different categories of unplugged wells. Are there? I guess my question is that are there mechanics associated with those wells, particularly in this subset of wells that you seem most concerned about, which is the ones that more recently had production? Is there any mechanical infrastructure associated with those wells that seem to have some influence over the fact that they are, while they're still shut in, they're still creating methane emissions?
Yeah, and I think it's to be shut in is just closing a valve at the bottom. You're isolating the reservoir from the atmosphere. But if you leave anything for 2 years in Colorado sitting outside, that valve's going to corrode potentially, and you're going to get gas that's bypassing it. So I can only assume that's what, I'm not a wellhead expert, but that's what I assume is happening. So anything that's unmaintained. So it's this idea of, should anything at pressure be left unmonitored and unmaintained? So I think that's maybe what is causing the issue. But without any further study, it's impossible to say, what actual thing is causing the emissions to happen. So. Okay.
Well, I mean, I guess I do find it interesting that certain areas, even in unplugged wells, are having less emissions than other areas, and I'm just trying to understand if there's any correlation between well depth or basin specific stuff, or technology that was utilized in those, or what that may be. Understanding that, at least my understanding of your data is that while you're providing an average, that average is not the appropriate way to look at it. It's actually, is mean the more appropriate way, or median, or what's the appropriate way to look at that? Because certainly that that average data that you're providing means that there's, it sounds like 3 super emitters that were associated with this study. That certainly, I mean, they're part of the subset, so I'm not suggesting that they get thrown out or not considered or anything like that. But, how do we maybe dive deeper into, what caused those super emitters to happen, and then what's working with these other ones? Because, the orphan well program is working as fast as it can to work through and get stuff plugged and abandoned. But at the same time, there's going to be some situations that, will have a well unplugged until the orphan well program can get there and plug it. And so I'm just trying to understand from your perspective, as you look at it, if you have any thoughts on that.
Yeah, it's difficult because what's likely to be true is if you go back to that well today, it's probably not emitting. Our repeat measurements were showing that this was exponentially decreasing to 0. So how many other wells had gone through this cycle, of dropping down to 0? And I think, it's just, yeah, it's very difficult to know. And I think one of the real difficulties is that it is such a difficult task to identify even a large emitter. So you've got something there at 75 kilograms an hour, and you think, oh, that's, that sounds very big, but you're unlikely to detect it unless you're driving past fairly slow within 100 meters. So if you were to drive past in a vehicle with a trace gas analyzer that can measure down to ppb methane, you're unlikely to be able to detect it unless the atmospheric conditions are correct. So I think it's, that's, I think, the real difficulty with abandoned well measurements is you have to get very close to them in order to detect anything that is, emitting. And it can take you a bit of time. We'll go to each wellhead, we will be there for about 20 minutes going around it and making sure that each, each part of it is 0 methane concentration. And even, the very, the small emitters, 4 grams an hour, it will maybe take 2 or 3 seconds for your analyzer, to find the right place that it's emitting. Other ones, the really big emitter, you could hear it, it was coming out, it was hissing out. And then when Arthur went back in winter, it was, it was frosted up. So I don't know if that answers your question some. But...
Well, I mean, it certainly gives me information about, all the considerations that go here, and it's really hard to draw conclusions from this, right? I mean, there's certain things that are clear, that there's some emissions that are associated with, unplugged orphaned wells. There's certain conclusion that plugged orphan wells aren't producing emissions in this. But as far as figuring out the details associated with why these unplugged wells are emitting, or to what extent, or what's causing that, I think is that's not what this study was. I think you're just indicating that there's emissions associated with that. And so, yeah, I appreciate that.
Thanks for your question.
Commissioner McGowan?
Thank you. And I really appreciate this conversation, because I think if we remember way back when we all kind of became a commission and had lots of folks testifying in front of us about what they were concerned about, many folks were concerned about older plugged wells, or even newer plugged wells that were emitting. And I feel good after this study that maybe Colorado is doing something right with its plugging program and the requirements that we have in place. And I think to Commissioner Messner and to Professor Riddick's points, that there's some other information that we have now that could point us or direct us to what we need to do in the future around shut-in wells. So I think I think we have some good, not specific what's really happening, but some trends and things that we have to consider as we move forward with the program. So thanks for the information. I thought it was very interesting, and I think it helps answer some questions that we've had about what's going on with our wells, but then maybe brought up some more questions for us to look at.
Sorry about that. Yeah.
Commissioner Cross?
Thank you, Mr. Chair. And Professor Riddick, could you remind me again what constitutes the recently producing orphan unplugged wells? How recently is the recently producing?
I can't remember. I think I went back and I looked at the GIS data. I think it was in the last 3 years. Was it actually did I see any production that was happening? I think that's a bit vague, but I think that's what I produced. That's how I generated the value. It was more of a binary thing. So looking at, is there actually production data? You go some of the wells out in Rangeley, they're just holes in the ground with wooden boxes around them. But could I actually find production data for these? In the last, well, I guess it would be the last 10 years or something. I was looking back, but I can't remember the number.
Yeah, I thought that was interesting. I guess to a certain extent, it also, as we look at financial assurance and we look at our plugging and abandonment requirements, the requirement if it's going to be shut in to plug it soon thereafter, if it's not going to be brought back to production, just looking at that number makes it that much more important if it's going to be recently producing and not brought back into production. That seems like that's obviously where a lot of the issue is. So I just found that very interesting. Thank you.
All right, I'm not seeing further questions. Professor Riddick, we really do appreciate presenting to us this morning. Let's take about 10 minutes and then we're going to hear from staff. So let's return at about, say, 11:40, 9 minutes.
Thanks a lot.
All right, welcome back. The Colorado Energy and Carbon Management Commission on a special meeting on October 16th. Deputy Director Larson.
Thank you, Mr. Chair. I'm going to share a brief presentation that staff has prepared to provide further context as to the efforts that are underway with the Orphan Well Program to monitor and measure for methane from plugged and abandoned wells. So give me a moment to get this into presentation mode. Forgive me. It always takes me just a bit. There we are. All right. So again, I'm Mimi Larson, the Deputy Director of Policy and Administration here at the ECMC. And today I'm going to be giving you a little more information about the Orphan Well Program's methane monitoring protocol. And with us in the meeting today is Dave Andrews, the manager of that program. So he certainly is here and available to answer questions that you have, as am I. So as you heard from Mr. Riddick, the CSU study has demonstrated that plugged wells that were tested by CSU are not a source of methane. They're not emitting methane into the atmosphere. However, as we did hear, unplugged wells within Colorado are in fact a source of methane emissions. And so the Orphan Well Program, prior to this study conducted by CSU, did monitor for leaks at wells that are part of the Orphan Well Program. And the results of the study that we heard today from CSU is going to be incorporated into the Orphan Well Program and will help to continue to influence how we rank wells that are in that program that have yet to be plugged, and help us to score when a well needs to be moved up the list for plugging, if in fact it is, emitting methane at a higher rate perhaps than other wells. So what is the Orphan Well Program doing right now to monitor for methane? There are several tools that our staff uses to monitor the methane emissions from unplugged wells. The tools are depicted here on this slide. Again, Mr. Andrews can go into more depth about the technologies that we use, but these technologies have been implemented recently. And in fact, we started using these technologies most recently with the grant monies that the Orphan Well Program received from the Department of Interior. As part of the Department of Interior's grant program to plug orphaned and abandoned wells, it does ask that states monitor for methane. And so we have been putting into place this methane monitoring protocol. And we are using that information to help us identify, again, wells that need to be plugged more quickly or sooner based upon their emission rates. Prior to using the technologies that were depicted in that prior slide, staff in the OWP program would usually rely upon olfactory, visual, or audible observations. So essentially out in the field, looking at a well, if they saw a well emitting emissions through the use of a FLIR camera, that obviously was a sign that there was something going on. If you could smell the emissions, or if you could hear well actually emitting and being, if that was audible, that would be a sign to us that we needed further investigation to determine to what extent that well was leaking. And obviously those the olfactory, visual, and audible tests, for lack of a better term, or observations, are still something that our Orphan Well Program folks employ if they're on site, in addition to the technologies that were noted earlier. So effective with this year's annual orphan site list, we are putting in place strategies for any well that has measured emissions of greater than 100 grams of methane per hour. That well would receive the highest venting leaking component score. And so again, when a well is brought into the Orphan Well Program, there is an analysis of that well that looks at a variety of factors. How close in proximity is that well to people? Is it near water bodies? All these various factors that are considered, and including, is that well leaking methane, and how much methane is it leaking? So if we find that there is a well that is leaking methane at 100 grams methane per hour or greater, that is going to receive the highest component score, and that will be a factor in determining when we are able to get that well plugged. So looking more closely at the data that was presented to you in the CSU study, we saw that there were 18 wells that were found to have methane emissions of greater than 100 grams per hour. And we wanted to provide you with more information as to the location of those wells. So 8 of the wells, as you see here in the slide, 8 of those wells were in Adams County, 3 were in La Plata, 1 was in Logan County, 2 were in Mesa County. There was 1 federal well located in Moffett, 2 wells in Rio Blanco, 1 well in Will County. And in parentheses, you see how those wells are currently, what the status of them are. So for instance, in Adams County, 4 out of the 8 wells have been plugged. And I won't read to you the status of the remainder of the wells, but we certainly are being diligent in getting these wells addressed as quickly as possible. And it is our goal, again, to get those wells with larger emissions that have been measured, to get them plugged and abandoned as soon as possible. Looking at those wells that had methane emissions measured of 10 to 99 grams per hour of methane, there were 39 wells. Again, this is a breakdown that shows the location of those wells, how many of the wells have been plugged, or what the process is for plugging those wells. And then finally, we see that there were 63 wells that had measured emissions of 1 to 9 grams of methane per hour. Again, location of the wells, what the status is. I think Mr. Riddick noted that quite a few wells that were measured were within the Adams County area near Denver International Airport. So that's why you've seen here that so many of the wells are in fact located in Adams County. And again, the Orphan Well program is working to get those wells addressed as quickly as possible. So we just wanted to, oh, forgive me, there is one more slide. There were 114 wells that did not have any methane detected. And you can see here, again, where those wells are located, the status of those wells. Not all of the wells that did not have any measurements for methane were not in fact plugged. So we see here there are 5 wells in Elbert County. Those wells have not yet been plugged, but upon the testing that was conducted by CSU, there was not shown to be any methane emitting from them. So, you know, again, this gets back to Mr. Riddick's comments that it's not always a perfect science to know why a well is emitting or not emitting. So here is just a final screen here, or final slide here, that shows the breakdown of those wells, what was measured, where they are, whether plugged or unplugged, and gives you just a little different visual as to what the data shows. And again, you know, for the data that we have received from the CSU study, it has been very important and helpful for the Orphan Well program to incorporate that criteria further into its risk assessment system, and to ensure that we are addressing those wells in connection with all the other factors that we look at as quickly as possible, those wells that have a higher rate of methane emissions. So with that, I'll stop sharing my screen and turn it over to any questions commissioners may have for myself or for Mr. Andrews. Commissioner Cross?
Thank you. I was going to say, it looks like we've lost Chair Robbins there. So at the very end there, you did note that I think you said it was 68 of the wells have been plugged that were measured by the CSU study. Is that correct?
I will have to look. Correct.
Does
68
that
wells,
mean-
yes.
Were a lot of those 68 focused on that 19% that were more recent producers that had higher emissions, or were they kind of spread out?
You know, looking back, I'll defer also to Mr. Andrews, but I know certainly the wells that had methane measured of 100 grams or greater, it does look as if a majority of those wells have in fact been plugged and are certainly on the list to be plugged. And then from there, it is just, you know, a smattering throughout the rest of the buckets of wells that have in fact been plugged since that testing.
You went through the other parts of it, efficiency purposes, etc. Okay.
Correct.
Thank you.
Commissioner Messer?
Thank you, Deputy Director Larson. I really appreciate the slides that you just presented, and you know, it's always good to see the quality of work that's being done. And you know, I think that the slide that talks about the 18 wells that have greater than 100 grams of methane producing per hour, and the fact that a vast majority of those have already been addressed in the Orphan Well program, and I'm sure we're already high in the plugging list anyway, based on other factors. But I mean, I think that shows the, you know, effectiveness of our program, and I really appreciate the Orphan Well program and Mr. Andrews, all the work that you do. Really appreciate that. Looking sharp today, by the way. And I think that the fact that you're now bringing in this other technology in order to be able to use that as an additional category to all the other categories that are incredibly important in determining the prioritization of these orphan wells, I think is, you know, again, another testament to the quality of work that you're doing out there. And so I just want to reiterate that it appears that you know, the wells that, you know, had the highest levels of emissions are the ones that were already high on the priority list and are already being addressed or have been addressed to a significant level, and then the other criteria still falls in line. And so I guess, a long way of saying, well done, and really appreciate that the work that you're doing.
Thank you, Commissioner. Any other questions from commissioners? Okay. Chair Robbins, I don't know if we have you back fully. Oh, we do.
Yeah, I'm here. I'm on a phone. My internet died. I was able to hear most of the questions. It sounds like the presentation is done and we have no further questions. And at this point, we're likely looking for a motion to adjourn.
So moved.
Second.
Very good. Thanks again for all the good information today. Really appreciate it. All those in favor of the motion to adjourn signify by saying aye.
Aye.
Bye.
Any opposed? Motion carries. See you in a bit. Thanks, guys.